Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. See the next numerical. The specific heat of water is 4180 joule per kilogram degree Celsius. How much the heat capacity of 2 kg of water? So specific heat is given for 2 kg of water, heat capacity we should find out. Given specific heat C equal to 4180 joule per kilogram degree Celsius, mass is 2 grams, heat capacity capital C equal to specific heat small c into mass of the substance. Here specific heat 4180 into 2, that equal to 8360 joule per degree Celsius. You may get it out. How can we get this formula? Means, see here, specific heat equal to small c equal to Q by m into delta T. Q by delta T means capital C. Capital C is nothing but heat capacity. So from this we can get heat capacity capital C equal to specific heat small c into mass of the substance. Same thing we use it here. Okay. Next, a substance of mass 2 kilograms absorbs heat 100 calories when its temperature ranges from 20 degrees Celsius to 70 degrees Celsius. What is the specific heat of the substance? So given mass of the substance 2 kilograms, convert that into grams, 2000 grams, heat Q equal to 100 calories. Difference in the temperature delta T equal to change in the temperature delta T equal to 70 minus 20, that equal to 50 degrees Celsius. So specific heat of a substance small c equal to Q by m into delta T. Substitute Q value 100 divided by 2000 grams into 50, that equal to 10 power minus 3 calorie per gram degree Celsius. So students, these are the numericals related to specific heat capacity and molar heat capacity. Now see the next topic. Here one more numerical is there. The value of delta H for cooling 2 moles of an ideal monoatomic gas from 225 degrees Celsius to 125 degrees Celsius at constant pressure will be given Cp equal to 5 by 2 R. Okay. So Cp value is given, temperature, initial final temperatures are given, we should calculate delta H. See the formula. Delta H equal to minus N into Cp into delta T. Here N means number of moles. So substitute that one, minus 2 into Cp value for monatomic gas 5 by 2 into R, and temperature difference this one. So finally delta H equal to minus 500 R. Okay. Next, important topic for IIT students. Listen carefully. Molar specific heat capacity at constant volume. See the definition. The amount of heat required to raise the temperature of 1 mole of gas by 1 degree Celsius at constant volume. Take 1 mole of the substance. If we want to raise its temperature by 1 degree Celsius, required heat energy is called molar specific heat capacity at constant volume, represented by Cv. Next, molar specific heat capacity at constant pressure. It's very simple. The amount of heat required to raise the temperature of 1 mole of gas by 1 degree Celsius at constant pressure is called molar specific heat capacity at constant pressure, represented by Cp. Next, the molar specific heat capacity at constant volume is related to the internal energy U of the ideal gas. How Cv and internal energy U are related means Cv equal to du by dt at V. V means at constant pressure volume, this one at constant volume, that equal to F by 2 into R. R means universal gas constant. F, what is F? Degrees of freedom of gas molecule. Here gas molecules have different types of degrees of freedom. 3 types: translational, vibrational, and rotational. Here we are considering 3 types of gaseous molecules: monoatomic, diatomic, and polyatomic. That means triatomic and any other. Based on the atomicity, we can classify the gas molecules in this way. Monoatomic means only one atom is present in the molecule. Diatomic, 2 atoms in the molecule. Polyatomic means more than 2 atoms, 3, 4 atoms are present in the same molecule. Those are polyatomic gases. These degrees of freedom is different for monoatomic, diatomic, and polyatomic. See one by one. For monoatomic gas, 3 types of degrees of freedom is there. All are translational degrees of freedom. Next, that means molecule exhibit these type of changes, translational changes. Diatomic gas, 5 degrees of freedom. In that, 3 translational degrees of freedom and 2 rotational degrees of freedom. Polyatomic gases, some molecules have 2 rotational degrees of freedom, some other molecules have 3 rotational degrees of freedom. How can we decide? Means this value depends on geometry of the molecule. How atoms are arranged in that polyatomic molecule, based upon their geometrical arrangement, rotational degrees of freedom depends. So some polyatomic gases have 2 rotational degrees of freedom, some other molecules have 3 rotational degrees of freedom. Okay. Next, the internal energy of an ideal gas at absolute temperature T is given by U equal to F degrees of freedom, F into R into T divided by 2. The heat given at constant volume is equal to the increase in internal energy of the gas. At constant volume, the supplied heat energy is equal to the increase in internal energy of the gas. The heat given at a constant pressure is equal to the work done by the gas due to increase in its volume plus increase in its internal energy of the gas. So here QP means heat supplied to the system at constant pressure. This value is equal to work done by the gas. Here we are supplying heat energy to the substance. Because of that, volume of the substance increases. Then some work is done by the gas, that is delta W, and also internal energy is increased. That's why the supplied heat energy at constant pressure is equal to QP equal to delta U plus delta W. Okay. Next, the difference between Cp and Cv is given by Mayer's formula. Remember this, Cp minus Cv equal to R. This is for 1 mole of ideal gas. This is called Mayer's formula. The ratio of the specific heats, also called adiabatic index, is given by gamma equal to Cp by Cv, that equal to 1 plus 2 by F. This ratio is also known as Poisson's ratio. Okay, important this, remember carefully. For air, gamma value is 1.4. This gamma value is used to define adiabatic process, that is PV power gamma equal to constant. Second one is speed of the sound in gases. In different gases, monoatomic gases, diatomic and polyatomic gases. So what is the speed of this sound? If we want to calculate, then suitable formula V equal to square root of gamma into RT by M. Okay. Now, monoatomic, diatomic and polyatomic, these 3 types of gases, Cv, Cp, gamma and degrees of freedom, in a simple tabular form. See here, for monoatomic gas, Cv value 3R by 2, Cp 5R by 2. Gamma means, what is gamma? See here, Cp by Cv. That means this value divided by this value. Then we can get 1.67. How many degrees of freedom? 3. All are same type. Translational degrees of freedom. Diatomic Cv 5R by 2, Cp 7R by 2, gamma 1.40. degrees of freedom 5, in that 3 translational, 2 rotational degrees of freedom. Last one, polyatomic, CV 3R, CP 4R, gamma 1.33, degrees of freedom 2 or 3 rotational degrees of freedom. We have to remember these CV, CP values for monatomic, diatomic and polyatomic. Based upon this, we can get atomicity of the gas. That's why we should remember. Okay students, we'll meet in the next class.